When we're working with radicals, it's traditional to not leave radicals or irrational numbers in the denominator of the expressions we're working with. You have an example here, 2 divided by the square root of 3. And like I say, we typically do not want to leave a radical in the denominator. So the question is, how would we get rid of that? And the process of getting rid of that is something we call rationalizing the denominator. We want to take this irrational number, square root of 3, and we want to remove it so that there is a rational number in the denominator. So to do that, what I'm going to do is I'm going to take this expression and I'm going to multiply numerator and denominator by the square root of 3. And I'll explain why in a second. But first of all, I can do this. I have a number, and if I multiply by this quantity, which is basically 1, something divided by itself is 1. We know that something multiplied by 1 will be the same after we've done that multiplication. So we can definitely do this. We can definitely multiply top and bottom by the square root of 3. Now you might say, well, why did I choose the square root of 3? What I did is I took this square root of 3 and I decided to repeat that because if I multiply across in my denominators, I'm going to get the square root of 3 squared. And this, I know, is my inverse property. The square root of 3 squared will be 3, a rational number. I've removed the irrational number square root of 3 and turned it into 3. On the top, if I just multiply by 2 by root 3, I get 2 times the square root of 3. And so here is my reduced value. 2 root 3 divided by 3 is considered the proper reduced form for 2 divided by root 3. That's rationalizing the denominator, removing the irrational number. Here's another example, similar. On our denominator, we have 2 multiplied by the square root of 5, which is one term because they're multiplied together. So to get rid of the square root of 5, what I'm going to do is what I did in the last case, is I'm going to multiply numerator and denominator by that square root. Because if I then multiply, I know that this is 1, which is why I can do this. Something multiplied by 1 means my new answer, which will look different, will be the same as the original. So 2 root 5 multiplied by root 5 would be 2 times the square root of 5 squared. And on the top, 3 times root 5 would be 3 times root 5. And then our square root of 5 squared will be a regular 5. Put that in brackets to distinguish it from the 2. And so I get 10 on the denominator and 3 root 5 in the numerator. This expression is equivalent to the original expression, but there is no irrational number in the denominator. How would this rationalizing of the denominator work if I was using a different index? So I have here the cube root of 8 over x, which I can break up using my division property as the cube root of 8 over the cube root of x. The cube root of 8 is a perfect cube, 2 cubed. And so that becomes 2 over the cube root of x. All right, let's just bring this down here. Now the question is, what do I need to multiply numerator and denominator by in order for my denominator to be radical free? Basically, I'm going to need this to be the cube root of x cubed, because then that would become x with no radical. So what would I need to multiply numerator and denominator by, given that this is x to the 1? I would need to multiply by the cube root of x squared, because multiplying I would add the exponents to get x cubed. And then the cube root of x cubed would be our x, radical free on the denominator, and then multiplying our numerators would give us 2 times the cube root of x squared. And there is my simplified form. The last situation that you need to be able to deal with in terms of removing radicals from the denominator are those in which you have 2 terms in the denominator, like we do here. Square root of 5 minus 4. The previous examples we looked at all had one term, and we talked about how to remove the radicals with those. How do you do this when you have two terms? Well, what we're going to use here is the multiplication of conjugates. And remember, conjugates are binomials in which the signs in the middle are opposites. One has a negative and one has a plus. If we multiply these two terms, we will get our terms, and we'll notice that our two inside terms cancel out. So what we're going to do is we're going to look at our denominator, the square root of 5 minus 4, and what I'm going to do is multiply numerator and denominator by the conjugate of the denominator, which would be the square root of 5 plus 4. Remember, we can do this because this section is just 1, and something multiplied by 1 will equal the same as the original starting value. All right, so let's perform the multiplication. Let's do the denominator first. We have conjugates, same terms except opposite signs in the middle. So we're going to have root 5 times root 5, which would be root 5 squared. We know that our outside and our inside terms, when we multiply, will cancel out. And so our last term will be negative 4 times positive 4, which is negative 16. In other words, our denominator becomes the square root of 5 squared, which is 5, minus 16. You'll notice we have no radical left in the denominator. On the top, we have one term multiplied by 2, so we have to distribute that. We could leave the answer like that, but we usually like to keep things with a positive denominator. So I could multiply numerator and denominator by negative 1 and leave my answer like that.